Okay, everybody, in this particular video we are going to talk about something called variation in our data, or sometimes it'll be called variance. How much variance do you have? Or you might think, how much do my data points vary from one another? If there's not a lot of variation, then they're normally clustered more closely together, like say with Hank Aaron's data points. But if they vary a lot or they're more spread out, then like Babe Ruth was, then it'll look a little bit different. So we already have one measure of variation, which is range. So, and range literally tells me how spread out are my data points. Okay. So that's literally what it tells me. And from our earlier videos, we know that all we do there is a simple calculation, high minus low. So that's easy to tell. However, there are some other measures of variation, so we want to talk a little bit about it. I mentioned before normal curves. Okay, and this is going to be important. It's a huge concept in statistics, and it's something that's going to stay with us the rest of the class. So in a normal curve, these are sets of data that seem to be naturally occurring such as in traits from genetics, or growth patterns. Okay, so this is normal. That's why we call it normal. Okay, what happens here is most of our expected value, or most of our values, are expected. And that word expected, I highlighted it last time, and I'll continue to highlight it because we're going to have something called expected value soon. So most of our values are expected to be near the mean. Or median. With few data points on the outside. And it doesn't matter if that's on the small side or the large side. So we'll say big or small. We don't care. Okay, so normally what this looks like, and I'll just go ahead and say it, like if we were talking about women's shoe size, we might expect most women, if I polled a classroom, a lot of them would probably have a size 7 or 8 right in there. Okay, so if this bar represents my mean, my average shoe size, let's call this shoe sizes for women. Okay, if this is my mean, then we'd expect most of my people to be in this area. And then we might have some stuff that looks like this. If these were 7s or 8s, maybe a lot of 6s, a few 5s, not many 4s, that kind of thing. We might have something that's like this. Maybe that's my 8s, 9s, 10s, something like that. Maybe my girls who are really tall basketball players might be way up here, and I don't know, maybe my small tiny dancers or something might be down here. But the idea is, remember we did this before, if I superimpose the normal curve, and in this case I'm going to put it on this histogram by barely touching the outside corners of each of these bars. And again, I'm just making this up. I don't have a data set or anything like that. We're just saying what if. Okay, so shoe size is one of those things that we expect it to be a lot of people in the middle, and then as we get out towards the really big sizes or the really small sizes, we expect there to be fewer women with those size shoes, right? So this is a naturally occurring genetic trait, right? You can't necessarily control the size of your foot. So because that's something that happens in nature, it's something that's just, it's a human characteristic, so to speak, we expect it to be a normal data set. So it has just a little bit out here, a lot there, and a little bit out here. Okay, this is also often called the bell curve. Or the normal curve. In stats, we call it normal. But you may have heard it called the bell curve in one of your classes or something like that. If you have a teacher who grades on the curve, is what they called it whenever I was in college, sometimes that's a good thing and sometimes that's a bad thing. I had a class where it was a graduate math course. It was very, very difficult. And whenever I went to go take my very first exam, it said, when I got it back, 43, which was, I was devastated. But then out beside it, it said B. It was like this, 43, B. That was my grade. So I made a 43, but the teacher had graded us on a curve, and so my 43 became a B. Now, what does that mean? It means that 43 was actually relatively high for this class, and come to find out, the highest grade in the class was a 68, and that guy had gotten an A. So even though he was not an A, this was not an A grade, right? This is a D grade, but he was the highest score. So what the teacher did was he graded on the curve. And he said, I need a few A's, I need a few B's. Most of my grades are going to be C's, because that's natural, right? And then I need a few D's and a few F's. So even though my score was legitimately an F, and it was a terrible score, because I was like maybe the third highest grade in the class, the teacher had made one A and put him here. The 68 came here. The 43 came here as a B. And then there were some C's. These were like maybe, so there was one grade in here. I think it was also a B. Maybe it was like a 52 or something like that. There were a couple of people in here that were C's. That really they should have been F's, of course. They were like 30s. And then on this end was maybe your 20s and your 10s. So he said, most of my grades are 30s. Those are going to be my C's. I'm going to stick those right in the middle. That's what that particular teacher did. So he wouldn't have had this many bars, right? He would have had a C, a B bar, an A bar, a D bar, and an F bar, right? So he said, most of my grades are 30s. I'm going to stick those here. People who got 40s and 50s, you guys now have a B. The 60 was an A. And then pull a couple of the 20s. Those are now D's. And then the guy who made in the teens, he's an F. Okay, so that was really nice, and I actually appreciated that because my grade was really, really terrible, and all of a sudden I have light at the end of the tunnel, and it's possible for me to make an A or a B in the class, even though I bombed that exam. So that was a nice bit of grading on the curve. I'll tell you, though, a not nice bit of grading on the curve would be if I took the grades from this class, because normally in this class students do really, really well. So normally I'll have maybe just a couple of C's and a couple of D's, but most people make A's and B's. Well, if I said I need this to be a normal class, let's just kind of draw that out for us. If it looked like this and I wanted it to be a normal class with a bunch of C's, some A's and some B's, D's and F's. So again, just trying to keep with that normal curve kind of thing. Okay. And I'll talk about the difference between this one and this one in a second. But if I looked at that and I said, oh, all my scores are up here in the A's and B's. Grades and stats test. Okay, if I said all my scores are up here in the A's and B's, but my average grade is, let's say my average, my mean, I'm going to stick that right in the middle. If my average was a 75, then now all of a sudden I've got a little bit of a range I can pull on, right? So maybe people from, say, 72 to 78, I'm going to give them a C. But that means that people who are 78 through maybe 84, I'm going to give them an a B, okay? Oh, I'm sorry, I messed up. My average score needs to be higher than this. Dang it. Let me try again. 85. 82 to about an 88. Okay, so if that's a 6-point space, then this would be like 88 to about 94. Yeah, that's better. 94 to 100. So if I've got a whole bunch of people up here in A's and B's, let me continue this down on a 6-point range. This would be maybe 76 to 82, and then this would be people who are, so if my minimum score, let's say 70 to 76, something like that. If my minimum score was a 70, even though for my purposes that's a C in this course, if I said, oh, I have to put this on a normal curve, then basically what's happening is I'm lessening my grade scale, right, to a 6-point range instead of a 10-point range. So 94s to 100s, you get to keep your A, but Mr. 93 here, I'm sorry, I just can't give you an A because I just can't. I need to have normal scores, so I'm going to pull your grade down, and you're going to get a B. The 88, well, they're fine with a B because they would have been having a B anyway, but I guarantee you my people who are 82s up to 88s, and I give them a C, they are going to be not happy, right? Okay, so that pulls them down. And these people here in the F range, 70 to 76, they're really passing, right? They're doing well on the material. They've got a C. So these guys should be up here, but because I'm trying to spread my grades out and make it more normal, this guy right here, they're going to be really furious when they get an F and they really made a 70 in the class, or a 70, even 73 or whatever. Okay, by the way, I don't grade on a curve, so Dr. Webster doesn't grade on a curve. So this will never happen in my class. I believe that grades are on a 10-point scale, and you get the grade that you earned. So, by the way, what that means in the stats class is normally Dr. Webster's grades look more like this in a standard stats class, and I've taught this class lots of times. What happens is if you look at it as, let me change these grades around. I don't know why I'm doing it backwards. Let's say this is an A, this is a B, this is a C, this is a D, and this is an F. Let me put them in order. And so normally what will happen is I have a lot of A's, I have more B's, and I have tons of C's. So that's kind of a normal thing. And it kind of looks standard, right? Okay, that looks a little normal. But the problem is that I'll have very, very few D's and none or just 1 or 2 F's. So what ends up happening is I've got this really tall peak here for my mode, but then it ends up trailing down like that. And I don't have this other end over here, so to speak. This other tail is what it's called. I don't have that portion of the normal graph, right? So it just starts right here at a peak. And it's tall, and then it's got this trailing tail over here, but it doesn't balance out. It doesn't look like a normal, so it's not normal. That's what normally happens in Dr. Webster's stats class. So then we start saying, well, what the heck is that then? It's not normal. If it looks like this, I'm going to make it more pronounced so that we can see it. Okay. This is a tail on the right side. Or what if, I don't know, we were in a classroom and we had 1 or 2, for whatever reason, maybe public schools were out that day, and so I had 1 or 2 young kids in my class that parents had brought with them whenever we measured people's feet. And then most of the class was up here. So if it looked like that, I'd have maybe a few measurements down here for the small tiny feet pulling the tail that direction, but the majority of my class would be right in the center. So this would be a tail on the left side. Okay. And probably if we did some calculations, we might be finding out, are there any outliers in this area? Because when we get this weird tail that's not symmetrical, okay, notice that the normal curve is symmetrical, right? Symmetric. Okay, meaning it looks the same on the left as the right. If I had folded it right down the middle, then I'd have a reflection over that mean. So it would look the same on both sides. So symmetric. But these guys right here, these aren't symmetric, right? So this guy right here with the tail on the right, remember we talked about Michael Jordan and how much extra money he made than the other geography majors? Okay, he would be an outlier for sure, and he's pulling the data that direction because most of the people, maybe they're in the 60,000 range, but he's way out here at millions, so he's pulling the tail that direction. So whenever you have that tail like that and it's not symmetrical, now you start wondering, are those outliers? Can I find out if they're outliers? And what we're going to do in this class, we've already done one check for outliers, which was using the box and whiskers. We'll actually end up with 3 checks for how we know if something is an outlier. It's really important for us to know, can we dump Michael Jordan's data? Well, on that case, yes, he's definitely an outlier. Or do we need to keep that data point? So do we need to dump these 2 kids who came to class who had really small feet, or can we keep them in our data set? So we need to know, and not just to say, oh, I'm going to dump it, but to say, oh, let's use some math. Oh my goodness, the math's about to get real in here. Let's use some math, let's do some statistical work, and let's figure out if I can really drop that or not. So these 2 graphs are not normal, and in fact they're called skewed graphs. Okay, so we need some words for this, and I always tell everybody, and it's weird because it's hard to maybe keep straight at first because people, for whatever reason, whenever I tell you which one this is, you're going to go, huh, that's not the way I would have thought about it. So what you need to do when you're trying to tell which skew these are is you need to look at the outliers. Look at the tail. Which side is the tail on? Because the tail is what's pulling my data in one direction or another. So this guy right here is right skewed. Or some people might say it has a right-handed tail. Tail, like, you know, the tail of a cat. That's this end that's just coming out. Okay, so what you're looking for when you want to talk about skew is you're looking to see which direction the tail is. Is it on the right-hand side of the data or the left? Well, the majority of my data is over here, right? Correct? This is like where my mean is and stuff like that. So the majority is right here. So a lot of times people want to go with where the data is, and I tell them, don't look for the majority of the data, look for that outlier. That's going to tell me which direction, if it's a right or a left-handed skew. Okay, so then on this one, of course, what? The tail's on the left, so this is left skewed. Even though the majority of my data is probably over here, right? All my students took their hand measurements and they're in this area. They're probably the expected values, right? They are the ones I would expect to see in my statistics class. So I'm not worried about them. I'm worried about these kids down here and whether or not they're causing me problems with my data. So I'm looking at these outliers, so then I say, oh, the tail's on the left, it's left skewed or left-handed. Sometimes you'll hear left side tail or something like that. But left skewed or right skewed are the 2 most common, I would say. Okay. Now for the symmetric one, and we already said this, but I'm going to bring it back up. Whenever we're looking at, let me just pull these over here. When we're looking at these 2, and they're both pretty normal looking, pretty symmetric. They've got this nice reflection down the middle. We've already said whenever I have that kind of normal data, the mean equals the median equals the mode, right? Or it's really close. So let's think about that. I already said the mean was in the middle on these guys, right? So if it's reflective, then it balances out on both sides so that when I average it, it's right in the middle. The mode would be the guy who happens the most. Well, that's the tallest bar, right? Okay, the tallest guy, that's also the mode. So in this case, that makes sense. The mode is in the middle, okay? And then whenever you're looking at the median, well, the median is always in the center of the data, right? No matter what. The mode is always a data point, and it's always the tallest whenever you're looking at a bar or something like that, okay? So the median is always in the middle. The mean in this case is in the middle, and the mode is the tallest guy. It's also in the middle. So we can see mean, median, mode. Okay, those are pretty much the same. But for these guys over here, what the heck's happening? Okay, for instance here, this is the mean. Okay, well, we hope it's the mean. But for sure, he's the mode, right? The most tallest. The most occurrences is the most tallest. So I'm going to take off that mean because I'm going to talk about that for just a second. Maybe that's not the mean on that one on the left skewed. And here's why. When I look at the Michael Jordan data, if everybody's making around 60,000 and he's way up here in the millions, what happens to my mean? It should be here, should be with most of my data points, but because he's pulling me to the right and because I don't have normal stuff anymore, when I average that, he's probably pulling the mean up, making my mean bigger than what it normally would be. Like if I average without him in there, okay, maybe the average is 55,000 or something like that. But when I average with him in there, maybe the average is 150,000 or something like that. If all of my data points but one are here and my mean is bigger than all those data points, I have a problem. It's causing a shift in my mean, and that's definitely skewing my data. Okay, and the same similar thing would happen here. Most of my data points are here, but because I have a couple down here that are really small, when I average them in, they may be shifting the mean, but in this case, it would be shifting the mean downward, right? Okay, now the median's always in the middle of your data, so wherever the middle is, you know, if you counted out there were 20 data points and you know, 20 of them and the middle ones, the 10th and the 9th guys are right here, then fine. The median might still be where the mode was, but the mean is probably shifted away from them. So that is not the case that the mean equals the mode equals the median in this case. So two important points here. Let me get them across. Your mode is always a data point. Okay, so it is not like the median where I might have to average some or whatever. Remember, this is the most occurring data point, which means it has to be a data point. It's not an average, it's not anything like that. So the mode is always a data point. So it's not going to be some weird thing. It's not going to be like I've got a mode out here in the middle of nowhere, right? It's going to be the tallest bar where the most data points are. That's what happens. Okay? And the other important piece is that your median is always in the center of your data. Now, that doesn't mean it's in the center of the number line or the graph or whatever, right? Because, do I have my Babe Ruth stuff? Yeah. So let's look again at those box and whiskers that we did last week. Whenever I look at Hank Aaron's data, okay, If I was looking at just the regular data, 10 to 50, well, that's a 40-point difference, which means that the middle of this number line would be right around 30, right? It's actually 10 to 47, so it would be a tiny bit less than the 30. But it would be right in there, right, if I was looking at the middle of the picture. But remember, I'm not looking at the middle of the picture. I'm looking at the middle of all the data points. So Hank Aaron, I think he had, what, 20, did he have 23 seasons? So there are 11 below and 11 above. And the 34 here was a median, or the median was a data point. But remember, for Babe Ruth, and again, it doesn't look like his median's in the center of his graph, right? But it is in the center of his data points. And for Babe Ruth, remember, his median is not a data point, and that's because there was an even number of data points. So there were 11 below and 11 above. Okay, so the median does not have to be a data point. It might be. So it might or might not be a data point. Okay. And then what about your mean? Okay. Your mean can be anywhere on the graph. Can be anywhere in the data. Okay, and it doesn't have to be a data point. It could be a data point, but it doesn't have to be. So let me give you an example, because most people would say, oh, it's not a data point. Okay, well, a lot of times it's not a data point, but it could be a data point. So let me give you a real fast example of that. If I had 3, I can't read and talk and write at the same time. 3, 5, 7, 9, and 11. Okay. So if I had 3, 5, 7, 9, and 11, if that was my data set, okay, it's a pretty simple data set. If I look at this and I say, well, the guy in the middle is the 7. 7 is the median because he's in the middle. Does everybody agree with that? Okay. And it is a data point because it was an odd number of data points. Okay, cool. The mode, there actually isn't a mode here. I don't have anything repeating, so I will just say no mode. Okay, because I don't have 5 different modes here, right? They're all the same number and they only occur once. But what about the mean, average? Well, I made these very specific so I could cheat a little bit. Okay, these add up to 14, these add up to 14, and this guy's in the center, right? So if I add all this together and divide by 5, then I'm going to get 7. Okay, so do the arithmetic, and if you don't believe me, check it on your calculator. But in this case, 7 is the mean and 7 is the median. Now, I don't have a mode here, but this data, so what's going on with this data since they all only happen once? Like if I put this on a bar graph, these should all be the same distance apart. Sorry. I'm being a little sloppy today. Sorry. 3, 5, 7, 9, and 11. Data set. Whatever. They're all what? 1 unit tall. So they're all the same all the way across. So this is frequency. This is data point. Whatever it was, who knows. This could have been, I was trying to take measurements of size of hands by cubes, and I only had 5 people, and they were all different ages, and they all had different size hands. So that would not be a good data set for trying to play with it. So there's no mode, and you'll see it's not really very symmetric, right? So, well, maybe it is symmetric. Maybe I could just draw a line right there. It would be reflective, so, but it's not necessarily considered normal, because normal data would have the mode in the middle, and I just don't have it. So it's kind of a weird data set, but I was looking for, look, 7 is the mean, and 7 is one of the data points. So it's not always like you have to add it up and divide, and then whatever weird number you get here is a decimal or something like that. That doesn't always happen. So just be aware that sometimes the mean is a data point, depending on your data set. All right. What if, since we're going through this, what if I had something that looked like this, and I'm just going to kind of sketch a curve. For whatever reason, we've got some bars, we've got some other bars. All right, so what if it looks something like that? What can we say about this? It might be symmetric. If I put a line down the middle, I might be able to reflect it across that and call it symmetric, right? But it's not normal. Oh, man. My pen's dying on me. It's not normal. Why not? Because it's got two modes, right? Here's a mode. And here's a mode. And we had a word for that the other day. I don't know what this could be. Maybe I'm taking shoe sizes, and I've got shoe sizes for men and shoe sizes for women, or something like that. So maybe I have a mode for women. Something like that. Okay. Mode for the women would be the smaller one, probably. And the mode for the men would probably be the bigger one, right? Okay, so if I had something like that going on, I would have something that's called, y'all remember? Bimodal. I know we used that word the other day. So those things are out there, so don't forget about them. Okay, the last thing I want to talk about variation before I move on to standard deviation, which I was gonna make this one big video, but now I think I'm gonna have to make a second video for standard deviation. The last thing I'm gonna say, just because this is dragging out a little bit, sorry. The last thing I'm gonna talk about is the types of variation. So let's look at that. Types of variation. Okay, and I said I was going to come back to these two normal curves that I had earlier. So let's look at that. This one, if you'll notice, was really kind of tight together. It was kind of scrunched together, right? And didn't have really long tails or anything like that. But this one, it seems lower and more drawn out, more spread out. Whenever I see stuff like that, and I know these were supposed to both be grades, but whenever I see stuff like that, I go, oh, look, this is tighter together. There's not a lot of variation in there, okay? The scores are really close, whereas here maybe the scores were more spread out. So that doesn't match with my scenario that I had there, but let's talk about that. I basically have three different things that can happen here, okay? I can have a graph that looks like this, okay? Kind of squished together and higher and that kind of thing. So if I compare that to one that looks a little bit more like this, and this is what normally a normal curve would look like, a kind of a standard normal curve, okay? And then I can compare it to one like that other graph that I had, where I'm like, oh, you know, it's really spread out and it doesn't bump very much, and they all are kind of about the same. So maybe there's about, you know, I might have something like this, but really the heights of all of those bars are pretty close. Whereas here I might have a little bitty short bar and then some taller bars and then a really tall bar, which tells me, because these are squished together, that most of my data points are going to be right here, right? So it's all very consistent here. Whereas this is like, you might have scored down here, you might have scored here. This might be Hank Aaron's graph, bar chart with a normal curve on it, and this might be Babe Ruth. This is more of what normally standard would happen. Okay, something maybe more like that, where we've got a little bit of a bump there, but it's not a huge difference. So here's what happens. How much range is in here? How much change is there between these guys and these guys? Well, not a lot, right? Low variation. Very consistent. Squished. That's the Webster word. I know it's not mathematical, but that's what I think is, wow, those data points are all stuck in there really close together, right? Whereas this one is considered to be moderate. A moderate amount of variation. Okay, so kind of standard. Some differences, but pretty standard is the way I think about it. That's in Webster brain. Okay. And then this one, you're like, oh, this is a lot of variation. This is high variation. It's not, nothing says here you're not necessarily more likely. I mean, yeah, there's a little bit of a bump here in the middle, but you're not really much more likely to get here than you are here, right? So chances are similar to be in the middle versus one of the tails. Sorry, I'm out of room there. Okay, but there's not a lot of variation. Your scores are about the same. So maybe, you know, there were 6 of these and 7 of those and 8 of those and 8 of those and 7 of those and 6 of those. So it's, yeah, it's different from the top to the middle, but it's not that much different, right? Because maybe it's 6 to 8 or something like that. So there's not a ton of variation in there. So we just got to see that I'm sorry, over here there's a lot of variation. You could be wherever you wanted to. It's here that they're scrunched together. Okay. Let's see. I already talked about skewed data does not have mean equals mode equals median. Remember that, please. Okay. I'm going to give you real quickly a data set so that you can see how some of these might look. So, and think about the different types of variation. What if I gave you the data set 1, 3, 3, 3, 200? What do you think that guy would look like? Is it symmetric? Is it skewed left? Or is it skewed right? And real quickly, just kind of sketch it out. And one of the things that I'll ask you to do on the test is just kind of sketch what this would kind of look like. So you might have a 1 and then a 3, 3, 3, and then a 200 way out there somewhere, right? So, and start doing the superimposing of the curve over the top, because that'll give you a feel for what it looks like. Something like this. Data set. Frequency. Okay. Well, what do we think? Well, in my head, I hear you saying, well, there's a tail out here to the right because there's this one guy out here that's a 200, and that guy is probably what? An outlier. Okay, so hopefully you've got a little sketch here. You know what it looks like. You've got this tail over here, and you would tell me it is a left-tailed or left skewed. Okay. So hopefully that makes sense. There's you a little example of that. And the opposite, of course, would be, well, what if there was a 3, let's say a 1, a 3, a 200, a 200, and a 200? So that's basically just the opposite of what we just did pretty much, right? So play with that for a second. Sketch it out a little bit. See what you think is going to happen. A 1, a 3, and then way out here, the 200 is the one with the 3 occurrences, right? Okay, so what do we think about that? If we superimpose kind of a normal tail or a normal-ish curve over it, do we think it looks normal? Hopefully you're saying, no, that's not normal. Okay, so where are my outliers here? They're probably over here on this tail. So this would be what? Oh, you guys let me say that wrong. See, this is the stuff that gets fixed in my head, or gets fixed in class. I'm sorry about that. I'm not going to re-record that. I'm sorry. I don't know if I said it right or not. I'll have to go back and rewatch the video. The tail here is on the right-hand side. This is a matter of me not knowing what's my left from my right. So the tail here is on the right-hand side. I'm going to have to go back and look at those other graphs real quickly. I'm sorry. Left and right. Yes, those were correct. Okay, good. Tail here is on the right-hand side. This guy is probably the outlier, so it's right-tailed or right-skewed. Hopefully somebody was watching that video and went, what are you talking about? That's crazy. And so now you've corrected your notes, I hope. Okay, so now we're saying if these guys are outliers, which they probably are, they are on the left-hand side. Sorry about that. And I still can't write. So they're left-tailed or left-skewed. Okay. That's the way those are. Sorry about that. Every once in a while I do a goofball thing. It happens to all of us, I'm afraid. Alright, so that's kind of the idea of what's going on. Think about variance as how much data points differ from one another versus the mean, because the mean will come in handy as we come along. And I was, like I said, going to make this one big video, but now I feel like it's been 42 minutes, so we're going to have another video for a different video for standard deviation. So hang on tight. Sorry about that. I talked too much today.